All right, you're on.
All right. Well, welcome to everybody who's joined us for this webinar on our Germany adventure. The CREATE Center, sponsored by the National Science Foundation, put together a study tour of Germany, looking at the renewable energy and energy storage developments in Germany so that we could bring it back to the United States, to our community college programs in the U.S. Our NSF-sponsored grant is specifically on energy storage, and it's about integrating energy storage into renewable energy programs at two-year colleges here in the U.S. For this study tour, we selected participants from 9 different schools across the country and had representatives maybe from 11 or 12 colleges that participated in the study tour as a whole. And a few of those are here with us today to describe some of the things that we learned. So I think, yes, our next slide tells you a little bit about those of us who are here today. Gabby Temple is our project manager, and she's working behind the scenes to make sure everything is operating smoothly. My name is Joel Shoemaker. I teach at Madison Area Technical College. I teach renewable energy classes and electrical apprenticeship classes, and I am a co-principal investigator on this grant. And I'll just be hosting things here and turning it over to the people who really know what they're talking about, who are Jenny Brinker, who teaches in the Energy Management program at Northeast Wisconsin Technical College, and Scott Litticoat, who teaches science at Green Bay Southwest High School. He was our one high school representative who came along on our trip and facilitates or represents, I should say, the connection that we are trying to foster between high schools and two-year community college programs to help bring students through from high school into renewable energy and energy management programs at two-year colleges. For this trip, well, maybe I should take a step back. Germany is part of the European Union, a very significant player in the world's economy, the 4th largest economy in the world, and with a population of about 80 million people. The size of Germany is about the same size as California, but it has about twice the population. As we will see, there's specific reasons about why we decided to visit Germany for this project, and we'll get into that in a minute. For this study tour, we went primarily to southwestern Germany, landed in Frankfurt, went through Stuttgart and Freiburg, and ended up in Munich. And so we'll highlight a couple of those stops along the way in this webinar. Germany, the reason why Germany was selected as the place to attend on this study tour is that they have progressed further along the integration of renewable energy into their energy energy generation system and distribution system than most other countries in the world. As you can see from the slide here, about a third of the energy produced in 2017 in Germany was from renewable sources. We don't have the same sort of data about their energy storage progression, but that is also similarly advanced compared to the rest of the world. And so that explains in part why we chose to do the study tour in Germany. This transition from fossil fuels to renewable energy and also now to energy storage has been sort of coalesced under the title of the Energiewende, which just means energy transition. And the 3 pillars are highlighted here on this slide. That is renewable energy sources, energy efficiency, so cutting back on the amount of energy that is needed, and then enhancing and redeveloping the grid so that it can be more flexible and be able to integrate sources from a variety of different areas in the future. And I believe at this point, we will turn it over to one of our participants to describe energy efficiency.
Thank you, Joel, and thanks everybody for listening in. This is Jenny Brinker, and I'm going to talk to you about, I guess, the one of the red dots you see on the slide, about a location that has some pretty cutting-edge energy efficiency technologies to go along with that pillar of the energy Wende that Joel just introduced. So that more left-turn red symbol represents where the city of Fryeburg is located. And the next slide will show you a picture of the downtown of the city of Fryeburg, which is nestled in Germany's Black Forest. Freiburg has had a strong environmental ethic since the 1970s, when it had some pretty heavy anti-nuclear protests. What you can sort of see in the middle of the picture is a car-free downtown, which has been car-free since 1973. And about the whole entire population, the same number, about 220,000 folks, ride their light rail system every day, which runs on renewable energy. So today I'm going to just show you a handful of cutting edge, energy efficient, and energy plus buildings that are in and around the city of Freiburg. Our first location is Buginger Strasse, which is a high-rise 16-story apartment building. You can see on the left the post-World War II era initial version of the building that had been transformed into a super energy efficient building in 2009. This project was actually initiated by a housing association that wanted to show this kind of energy efficient renovation was possible. The city of Freiburg stepped in and partially funded this project, which cost 13.5 million euro and took about 1.5 years to complete. The colorful building on the right-hand side has a compact insulation, complete thermal envelope, which is separate from those balconies that you see. And like many buildings that we saw, this building is actually heated from a local natural gas-fired combined heat and power plant. This building not only uses heat recovery in its whole building air ventilation system in the air handling unit. It was pretty interesting to learn they also used heat recovery in the flue pipes of the bathroom and kitchen vents. Overall, you can look at the numbers here. The energy was reduced by 78%. And if you want to compare the performance to the United States, the average United States high-rise building uses between 50 and 78,000 BTU per square foot. All right, on to the next slide. This one's pretty interesting to look at while I tell you about it. It's called a heliotrope, and you can kind of picture this thing moving, right? It will rotate towards the sun, which is the meaning of the word. And it's really a feat of sculptural architecture built in 1994 with timber construction. And the timber construction was used to reduce the overall carbon footprint of the construction materials. And we'll see that in additional buildings coming up. The cost would be about $420,000 in today's dollars for a 2,150 square foot home. It was all paid for in cash at the time because it was kind of impossible to mortgage this construction. You are looking at not only a pretty cool looking building that rotates, but the features you can see that might look like handrails are actually solar thermal collectors that heat showers and domestic water for like the washing machine. You can also see on the top there are solar panels that have dual axis rotation to maximize the amount of solar energy they can collect. Overall, this house meets a passive house standard, which the European Union has adopted. Passive house essentially means a house so insulated that it barely needs heat. Next door to the heliotrope, you see in this slide, is the solar settlement, which was built in 2000. This is really another first of its kind, kind of slew of these I'm showing you, first of their kind. This one consists of housing that produces more energy than it consumes. This was the first place many of us had ever seen solar panels that are used as roofing materials. There's no shingles underneath those solar panels, and they're overlapped like roofing tiles. This project, much like the heliotrope, was privately funded, but in this case, the funding has an interesting story. It was raised by a chocolatier turned building entrepreneur. And the construction costs were just 12% more than standard construction, which is pretty cool considering that the housing units are net positive energy. And just down the street, the next slide will show you a picture of the Sunship, which houses the Eco Institute. This is a multi-use office building structure. And again, another first, it's the first positive energy multi-use office building. There's no mechanical cooling in this structure, but instead the cooling is done with ventilation during the evening cool hours, and which is another feature which is different than we would often see in commercial buildings, is that the folks who work in this facility can actually open their windows and utilize the outdoor air for air conditioning. Other energy saving attributes that you don't normally see in the United States include 1-inch thick vacuum panels on this building. That's sealed vacuum capsule walls that provide a higher R value from preventing conduction, and a complete thermal envelope. I had never heard of phase change interior walls before we visited this space. The plaster boards on the interior walls are actually made of a paraffin material that during its phase change provides additional thermal, heating and absorption for cooling as well. So pretty unique strategy. And also, it's kind of hard to see the external blinds. External blinds were kind of common in Germany, and they overall prevent heat loads on the interior spaces that happen with interior blinds. Okay, I've got one more really cool place to show you, and this is the world's first Net Plus Energy municipal building. It's the Freiburg City Hall, which opened in 2017. And again, this is a timber structure like the heliotrope building. This one's timber and concrete to reduce its carbon footprint. And you can see a lot of solar panels on this facade. And even if, Gabby, you make another click, it zooms in on it. There's overall 220 kW of photovoltaic power all around this building. And the orientation of the panels provide effective shading from heat load. The building is actually heated and cooled this time with geothermal heat pumps. I should also mention there's panels that you don't see in the picture. They're on the roof. And I had never heard of these, but they're actually hybrid panels that have both PV and thermal solar collection ability. All right, that's it for Madison's sister city, Fryeburg, Madison, Wisconsin, sister city. Scott's up next to tell you about another great place that we visited.
Great. Let's see if I've got.
It should be yours now, Scott.
All right, I'm hoping so.
There you go.
Okay, so I'm going to back up a little bit. There's where I want to start. Hi, I'm Scott Litticoat, and in addition to being the high school teacher that went along, I also teach a high school class with students who want to learn about energy efficiency and renewable energy. So I've got a little bit of experience in that area as well. Welcome everybody, and thanks Jenny for a great job to get started. What I'm going to do today is I'm going to review the small rural village of Wildpoldsreid. And that's a village that embodies all three pillars of the Energiewende, the energy transition, but I'll be highlighting these two that are on the screen: renewable energy sources and a modern smart grid or microgrid. This slide is a terrain view of Wildpoldsreid, which is located toward the bottom center. Running through the center of this view is an agricultural corridor. We've got forested ridges and hills. The dark green that you see here, they're located east and west. The eastern or right-hand ridge is higher, and it provides a significant wind resource. Keep in mind as I go along that this is a small rural agricultural village, population of 2,600 citizens. And also worth noting is that this village was not touched by Allied bombs in World War II, so it did not have what I sometimes thought of as the advantage that other German cities had of starting over from scratch after the war. Wildpoldsreid is located on the 48th parallel. This is very noteworthy when you consider its solar resource. As you'll soon see, Wildpoldsreid produces over 80% of the energy it consumes in solar power alone. And at 48 degrees north latitude, Wildpoldsreid, and most of Germany, by the way, is north of almost the entire continental United States. What we see today in Wildpoldsreid got its start in 1998 when the mayor and the city council adopted WIR 2020, which was a leadership plan. The plan combined green building and water protection with the goal of producing all of Wildpoldsreid's electricity by 2020. That goal was passed long ago, as was the goal you see here on a slide you're going to see again later, a slide that summarizes all of the local resources available to meet the goals. So let's take a look at the most important of those local energy resources one at a time. As mentioned earlier, there's a significant wind energy resource on the hilly ridge to the east. If you look closely at this slide, you may be able to make out the profiles of a few of Wildpoldsreid's wind turbines. I don't know if you guys can see my cursor moving, but they are there to be seen. There's a substantial biogas resource available in the agricultural corridor picture. Solar PV and solar thermal is found on many of Wildpoldsreid's homes, businesses, and public buildings. And finally, the citizens of Wildpoldsreid, who the leaders of this village would say are the most important energy resource of all. Pictured here are several of the 11 wind turbines off to the east. They have a generating capacity of over 12 megawatts. Here is one of the 5 biogas plants that produce both heat and power for the village. The biogas is produced and pipelined to the village where it is burned to produce electricity. The heat produced in that process is not wasted, but it's used to provide wintertime heat for Wildpoldsreid through a district heating system. In this slide, you see the distribution system being installed. Wildpoldsreid has 2,100 square meters of installed solar thermal capacity and 5 megawatts of solar PV, most of which is installed on private homes. On this slide, you also see and meet for the first time Gunter Mogeli, the deputy mayor since 1996, and probably the most important leader in Wildpoldsreid's renewable energy efforts. Some citizens own electric vehicles. To encourage this type of transportation in the village, Wildpoldsreid purchased 32 additional electric vehicles, and those are leased to local residents. The village has an emergency generating system, as well as a moderately large 138 kW battery storage system, which also helps stabilize the local grid by receiving or discharging electricity on command. All of this, Wildpoldsreid's entire electric production and consumption is under digital management and control. Regional utility AUW and Siemens Automation Technologies combined to test Project IRENE here. IRENE stands for Integration of Regenerative Energy and Electric Mobility. 200 digital measuring devices were installed at key locations throughout the village. They feed information to the digital brain of the system, which distributes electricity, works to optimize the system, and maintains the stability of the network. Wildpoldsreid is now working with IRENE Generation 2. Wildpoldsreid then has all of the necessary parts to claim a fully functioning microgrid or smart grid status. It has digital energy management. It has large-scale battery storage. It has distributed energy resources. And it has a local bidirectional energy grid. So Wildpoldsreid is not a work in progress or an experimental model. It's a village with a working, fully functioning smart grid or microgrid. Now compare this slide of the American grid, which might be called the large-scale producer one-way model for electricity distribution to the end user, to that slide. Could this, what you're looking at right here, can this be the future here in the United States? So in summary, the energy village of Wildpoldsreid, it's a village of 2,600 citizens. Maybe it's better to call them what they call themselves. They call themselves prosumers, a hybrid of the words consumer and producer. To be sure, these 2,600 prosumers have good leadership. Once again, this is Gunter Mogelli. He's wearing his Green Bay Packer cap, gift from me, the deputy mayor since 1996. However, Gunter deflects most of the credit for Wildpoldsreid's achievements to its citizens and their intelligent use of locally available resources. Gunter would say these resources: biomass, wind, PV, small positions in both hydro and local wood biomass, a smart grid, and energy storage, battery energy storage. Those are driven by the most important gear in the system: citizen participation and private ownership. And it's hard to argue with him. Citizens approved the original plan in 1998. Today, there are more than 350 owners of solar PV and solar thermal systems, and there are more than 400 private investor owners of the village's 11 wind turbines. Only citizens of Wildpoldsreid may participate. And look at the results. Just look at the results. Wildpoldsreid's consumption is shown in purple, about 6,200 megawatt hours annually. Biogas alone, the light green bar, surpasses that. PV alone, the yellow bar, is close. And the three bars to the right, representing 3 wind projects that total the village's 11 turbines, each of the 3 of them produces more energy than Wildpoldsreid uses. This is a village that produces 7.5 times the energy it uses. That's the story of Wildpoldsreid. Can it, will it become a model for the many communities just like it in the United States? And with that, I'll turn things back over to Joel for the rest of the ride. There we go.
Excellent. Thank you, Scott. Thank you, Jenny. As these 2 examples illustrate, oftentimes as we are traveling through Germany, we felt like we were taking a look into the future, hopefully, for us here in the U.S., both with the renewable energy integration into energy production, as well as energy storage and the flexibility with the grid that Scott was highlighting there with the microgrid example. Both Scott and Jenny have said they are willing to hang around and take some questions. So if anyone has questions, you can type them into the chat, or if you want to unmute yourselves, ask questions, and they will be happy to answer questions.
Yeah, hi, Wes. Asking a question. Able to hear?
Yes.
Yes.
Oh, asking about additional details of the storage. What batteries and how that worked.
Joel, maybe you could take that one with your expertise on battery a little bit better than mine, because we did see examples of a lot of different types.
Yeah, yeah, that's why I'm struggling to think of the exact answer. We visited a number of different sites, both manufacturing facilities as well as some research facilities at universities that were focused on energy storage, focused on batteries. And the batteries, or the manufacturing, the industry that we saw was lithium-ion batteries of several different chemistries, and ranging from, sort of residential scale battery systems to utility or grid scale battery systems.
Well,
so there's quite a range.
What about Wildpoldsreid? Did they have like a container, shipping container, several full of batteries?
Yes, and Scott, correct me or help me fill in the details. I mean, my memory was that was part of a pilot project with one of the utilities, lithium-ion batteries, and if I remember correctly, and you can help me, Scott, that was being controlled by the utility about when it would be implemented. Does that sound correct?
That sounds pretty accurate to me. I guess what impressed me about the lithium-ion batteries was the way that they could be upsized and downsized to just about any size you really wanted to. Just about everybody had small lithium-ion batteries, which could be put into larger groups, which could be stacked into even larger groups, and then depending on what size you wanted, you could get like a semi-trailer of various sizes that could be plopped on a cement slab and put into service very, very quickly. So I don't know if I'm addressing your question there, or was there more to it?
No, that was it, to see what kind of technology, what type of battery, and how big. It sounds similar to what they're using in the US at these utility pilot projects.
It was nice to see. We went to a convention at the end. It was nice to see that there was research into other types of batteries. And one of the ones that I found kind of interesting, and again, Joel, you can help me out here a little bit, was a vanadium flow battery, which they say has to be made much larger, and it's a good deal heavier. But vanadium, the claim is that it's easier to come by, and that it will discharge and recharge. They were using the word infinitely, or in other words, many, many, many times more than lithium-ion batteries will. So it was neat to see that there was also research and attempts at innovation outside of just lithium-ion, which everybody seems to be rushing toward right now. Yep.
The example there in Wildpoldsreid was, I think, specifically, as you were indicating, Wes, a pilot project, and similar to the ones we've seen in the U.S. I think the thing that struck us that is sort of different than the U.S. was, for example, half of all the solar projects that are being installed currently are being installed with batteries. So they're much further along in terms of the percentage of renewable energy projects that are from the beginning being installed with batteries.
So,
and part of that, if you're wondering why, in addition to cost savings that the cost of the batteries coming down, part of that is a result of the policies. The initial part of the Energiewende in terms of trying to encourage renewable energy was feed-in tariffs that were very significant. So anybody who had any inclination to put in renewable energy, there was definite payback. As that has been reduced, we're now getting to the point where the people who first got those contracts for the feed-in tariffs are facing the point where those are ending, and they're going to have much more benefit from self-consumption of their energy production rather than selling it to the grid.
Right. So with these batteries being put in with solar, are they still doing grid tied and the batteries are just there for grid support, or how does that work?
There's still, as all the ones that I heard about anywhere, still, yeah, grid tied, but it was focused on self-consumption. This is an impression, not necessarily the survey that we did, but my impression was to focus on self-consumption of the energy that they produce with their renewable energy.
Wow. So you make solar on your roof daytime and then store it and use it back through the batteries at night at your own home.
Correct.
Yeah. And energy rates over there ran into 30s, close to 40 cents per kilowatt hour. And with the price of solar and batteries coming down, there's still an incentive to apply solar to your home and then battery storage, so you don't have to pay those kinds of rates to the utilities to use their electricity.
Very neat. Well, I didn't want to hog it all in case somebody else asked a question.
Or if you've got another question, fire away.
No, the storage component was what I was most curious about. I'd visited Germany a few times and seen, yeah, the proliferation of solar and wind, and been very impressed, but never anything for storage. And obviously in the US, and a lot of industrial customers are all investigating storage, just can't make it work economically. So very curious about that in Germany.
Well, Germany's bringing the price and the management of the technology, the price for the management of the technology down. So we're going to see, I'm convinced we're going to see more and more of it. And the military has is moving in the direction of large-scale storage at some of its bases. So it's coming.
Sure. Well, thank you.
You're welcome.
Are there any other questions?
Okay, and I'm not seeing anything on a chat here, unless somebody else sees something.
Nope. Well, Scott or Jenny, did either of you think of anything that you wanted to add that you forgot first time around?
Thanks for asking, Joel. I kind of wasn't sure if anybody mentioned the flywheel that we saw.
Oh, sure.
I guess when you ask about energy storage, just a couple more things to add. We did see some flywheel storage. It had a very long payback, but it seemed to be the best solution for storing energy from the light rail system in the city of Fryeburg. So they're able to store the braking energy in the flywheel and then immediately discharge it back onto the light rail system lines. And in addition to that, I also thought it was interesting that at the solar convention that we went to, there were still quite a few vendors and manufacturers of lead acid deep cycle batteries. So those are still in play. And I think one of the most recycled materials or products in the world. Other than that, that's, I guess, what I was just thinking of chiming in about. Unless anybody thought of any more questions, we welcome your questions.
Well, while people are thinking of questions, I'll just mention, as you can see on the screen, we will be doing another webinar on January 10th. We have developed a small-scale battery lab activity, and we'll describe what that is, how it works, how you can build it either yourself or with your students, and also the lesson plans that Scott has written to go along with that lab. So we'll be doing that on January 10th, and it'd be great if you would like to join us for that. Also, our website, if you haven't had a chance to look at that, at createenergy.org, is a great place to find additional information and resources. Have more lesson plans that are located there, as well as examples of model programs or classes in different areas, and information about the professional development training that we do in the summer. So with that, if anyone has thought of any other questions, we'd be happy to answer them.
All right.
All right, well, if not, thanks for attending, and it was fun to do this. Thanks, Joel and Gabby. Jenny, good to talk to you again.
Yep. Thanks,
Excellent.
everybody.
Yes.
Thank you.
Have a great afternoon and a good weekend, and we'll look forward to talking to the rest of you soon.
Yep. Thank you all.